This video is on statistical operations on arrays. Let us first understand the axis of an array. NumPy calls the dimensions as axes. Thus, a two-dimensional array has got two axes. Axis 0 for the column, which is also called as column axis, and axis 1, which is for the row axis. The number of axes is also called as the array's rank. Now let us understand the statistical operations first on a one-dimensional array. The function max finds the maximum element from a one-dimensional array. Likewise, the function min, sum, mean, std is the function for the standard deviation of the array. Let us understand this with this example. Suppose you have a list called confirmed cases March, which has got these four values 550, 670, 980 and 990. From this list, you create an NP array, which is called as summary. Now from this one-dimensional array summary, you will find out the maximum element, the element with the maximum value. That can be done by simply writing it as summary.max. Summary is the name of the NP array which you have created, and max is the default function which is available in NumPy package. So by writing summary.max, you will get the maximum element from the one-dimensional array. That means your output will be 990, which you can see here as the first row in the output. Maximum element is 990. Likewise, you can use summary.min, summary.sum, summary.mean and summary.std for getting the minimum element from the array, sum of all the elements from this array, that is 550 plus 670 plus 980 plus 990, which will give you 3190. The mean of all these values, which is coming out to be 797.5, and standard deviation with the function summary.std. Now, let us apply these. Now, let us apply these functions to a two-dimensional array. First, we have two lists here. One is cured cases in March and another is death cases in March. We use nparray function, np.array function to create a matrix which we name it as matrix 1. This matrix is now a two-dimensional array with 2 rows and 4 columns. The first row consists of data as 20, 27, 32 and 52, and the second row consists of data as 201, 310, 670 and 770. Now, let us apply these statistical functions on axis 0, that is column data. When we write it as matrix 1 dot max and in bracket we write it as axis equals to 0, then we are actually finding the maximum element in each column. That means we have 4 columns here, so we will get 4 different results which will be stored in a row vector, right? So what we will get is 201, which is the maximum out of 20 and 201, and we will get 310, which is a maximum out of 27 and 310, Likewise for the other two columns. Similarly, we can apply min function, sum function. When we apply the sum function, you see the output here. You are getting the first output as 221. This is actually the sum of 20 and 201. Likewise, the last result is sum coming out to be 822, which is the summation of 52 and 770. Similarly, you are applying the function matrix 1 dot mean for finding out the mean in each column, and matrix 1 dot std with axis equals to 0 to find out the standard deviation in each column of this two-dimensional matrix. Same way you can apply the statistical functions on row data, that is with axis equals to 1. If you write matrix 1 dot max and write it as axis equals to 1, then it will give you the maximum element in each row. Since we have two rows here, so we will have only two different outputs, and those outputs will be stored in your row vector. Look at this, what we are getting back as an output. We are getting it as 52. First value, 52 is the maximum element from row 1. And we are getting the output as 770, which is the maximum from row 2. Likewise, we can apply matrix 1 dot min with axis equals to 1. Similarly, we can apply the sum function, mean function, and standard deviation function. So this was all about using statistical functions on one-dimensional and two-dimensional arrays. Hope you can apply the same on n-dimensional arrays. Thank you.